Hey guys, welcome to question MM183 of the Maths Methods Fortify study guide. So we've got this question: the curve of y equals 2x squared plus 8x plus b has a tangent with equation y equals cx take 13 on 2 at the point -3a. So that's an a, not a 9, just in case you can't see that. Where a, b, and c are real constants. Find the values of a, b, and c. Cool. So we need to find a, b, and c. So first things first, guys, is to recognize that the tangent has an equation cx take 13 on 2, which means that the gradient of our tangent is c, right? Because we have y equals mx plus c, and in this case, the m value is our c. We also know the equation or most of the equation of the original, which means that if we find the gradient function of this original and equate that to our gradient here, we should be able to find it. So let's just work through it. It's going to be a little hard to explain without just kind of going through it. So we know that our original function, I'm just going to rewrite this, is 2x squared plus 8x plus b. And the gradient at any point on this graph is equal to dy dx, which is 4x. So that 2 comes down and take 1 off the power, plus 8. Awesome. Now, the good thing here is that we've actually eliminated this b for now. So we're not going to have two different variables in this equation because the b just turns to 0 because it's a constant, right? So we know that the gradient of our tangent is equal to c, which is at the point x equals -3, right? So c, because c is our gradient here, 4, and we know that that occurs at -3a, which means our x value is -3. So we get 4 times -3 plus 8, which is -12 plus 8, which is -4. So immediately we can tell that c is equal to -4. So guys, this is a 3-mark question, and that would be your first mark there, finding out what c is. So from here, we can say that we now know the actual equation of our tangent, which is equal to -4x take 13 on 2, because our c is -4, and I've just subbed that in there. Now, we know that the point where the tangent is has a y value of a at x equals -3. So at this point where the gradient is -4 and the x value is -3, our y value is a, which means that a is equal to -4 times -3 take 13 on 2. From here, guys, 12 take 13 on 2, which means that a is equal to 11 on 2. Awesome. That's our second mark. So what we've done is we've found the actual equation of the tangent by deriving the original function, subbing that gradient back into the tangent, and then finding the y value at the tangent, which gives us our a value. Cool. From here, we know that the point that we're passing through is -3, 11 on 2. And we know that the tangent not only goes through that point, but the original goes through that point, right? Because if it's at a tangent, they have to have the same point at that coordinate, which means that we know that y equals 2x squared plus 8x plus b, and it's passing through this point here, which means that we can just sub this coordinate in to find b, which means that so 11 on 2 is our y value, so we sub that in for y, equals 2, -3 squared plus 8, -3, plus b. Awesome. From here we get 11 on 2 equals 18 take 24 plus b. And then from here, b is equal to 23 on 2. Sweet. And that's our third mark. So you can leave it like this. You'll still get all full marks, but I actually like rewriting it and saying a equals 11 on 2, b equals 23 on 2, c equals -4. And then just squaring it off with a red pen. So guys, whenever you're doing questions in exams, just get a red pen and just square off your answer just so that the examiner can see if you're right or wrong straight away. Just makes it really easy for them. So guys, that's question MM183. If you have any questions, just hit me up in the comments below. But otherwise, have a great day.